has the collaboration with IBM and another collaboration with Amazon Web Server AWS. AWS provide us the infrastructural and technical supports for running our codes, cloud computing and virtualization, and IBM provide us the technical support for conducting this business analytics courses. Similarly, EC has a collaboration with Texas Instruments and IBM. Civil Department has the collaboration with the NICMAR Construction Management Institute, renowned Construction and Management Institute, and Mechanical Department has the collaboration with the Bosch and Telbravo, like this. Now, several research works are also going on. Few PhD students are working in this university. We have started enrolling the PhD students from 2016 onwards. So, I am going to present one of our PhD work, that is the proposal for human psycho-emotional mapper based on the control stimulus environment. So, why this is required? Before going into this entire topic, let us see that in the next few minutes these are the topics that I am going to discuss. Now, the motivation behind this is we know that in the next generation is coming to the generation of robotics, where even how many of you have gone through this book, Yuval Noah Harari? I don't know, but he has predicted that in the next 50 years there will be two kinds of people. One will be the useless people who will be controlled by the robot, and another will be the useful people who will control the robot. And not only that, in the company's board of studies, there will be the robots will be one stakeholder who is going to take the decision. But are the robots are that much of intelligent without the emotions? Because we have the emotions, but robots doesn't have the emotions. Emotion is what? Emotion is basically the human experience, day-to-day experience based on which is influenced by its cognition, perception, anticipation, etc. Such as learning, communication, and even rational decision-making skill. Now, our main job is to create one psychobiological pattern of human, like its gauge behavior or the brain or the psychophysiological responsiveness, which is called an affective computing. This affective computing is sometimes also called the emotional AI, which is basically used to collect the human behavioral pattern, like the eye movement or the body language movement or the facial expression or the facial motor responsiveness based on some event. If an event is thrown into in front of a human, how he is behaving on that. So these data are collected, and based on this, one psycho-emotional pattern of a particular human being is being generated. So, and its uses is multifold. We can use it to identify a criminal, or we can use this for sentiment analysis also. Right now, these types of sentiment analysis works are going on, and ready-made tools are being available through IBM Watson Analytics or AWS Recognizer. So, so in case of these types of human computer interaction, how can we get the data? So either we can get the data through the keyboard or mouse or the other input devices, where gradually the users is giving the data through its behavior change and or the user experience in the browser, because a particular human is most of the times is spending browsing the nets or browsing the computers. Now these data are also being collected every time. Perhaps those who have the iOS devices, recent iOS 12 also have the capability of taking your data, and he will show day-to-day analytics that how much time you have spent in productive apps, how much time you have spent in gaming apps, how much time you have spent in Facebook, and every data it will show you. And based on this, it will show you at the end of the month the psycho-emotional behavioral pattern also. And or either you can take the voice command, voice modulation. Based on voice modulation, your human emotional behavioral pattern or some other biometric features, but these are vulnerable in nature. Suppose if you face a lie detector test, and when you are trying to suppress some truth, that case it will be identified by your irregular nature of your pulse rate or your heartbeat, right? So but the benchmark of the of your normal heartbeat is quite different from the heartbeat which heartbeat response that is we usually got from a person who is geographically situated in some other locations, such as Africa. African people's heartbeat starts from 120 and more than that. So I cannot say that it's a benchmark value that we are getting a particular biometric features we are getting. So from that we cannot create a human psycho-emotional behavioral pattern from this one. But the fourth factor, which is very important, the emotion. You can suppress the truth, but you cannot suppress the emotion for a long time. It will outburst at any point of time because it is combinations of large numbers of emotional responses. Now, do you know how many emotions are there? How many emotional combinations are present that has been actually first time it has been come into pictures by Robert Plutchik in 1981. He told that the total number of human emotions are around 34,000. That time he has invented this much of. So is it possible to quantify 34,000 of different types of human pattern, and based on this create your own structure? So it is hitherto impossible. It is not possible to navigate the turbulent waters of emotion, its different intensities, compositions, or without getting lost. So one solution he has given, that is the Plutchik wheel of emotion. So in that Plutchik wheel of emotion, he told that out of the 34,000 emotions, we have 8 basic emotions. So it may be joy, it may be sorrow, it may be apprehension, it may be trust, it may be anticipation, it may be anger, it may be disgust, sadness, surprise. These are, and rest of the emotions are the binary combinations of the other emotions. Like if we combine fear with trust, we will get submission. If we combine fear with surprise, we will get awareness. If we combine surprise with sadness, we are going to get disapproval. So in this way, so if I combine two emotion to get another emotion, that is the binary emotional pattern, and binary emotional dyads actually, and if I combine 3 emotions out of this, then I get tertiary emotional dyads. So in this way, combining the other emotions also, we are going to generate some new emotions. So in this way we can generate the total number of 34,000 emotions out of the available emotions. So these are the total numbers of emotions that Plutchik's wheel of emotions have already devised. Now this model is a 3D model, and in this 3D model, a conic model. So the upper side, the intensity is high, the emotional intensity is high, and when it is going to converge at the end, the intensity becomes lower. So this basic emotions will take as our input to generate our human psycho-emotional behavior stimulus pattern, that is anger, anticipation, joy, trust, fear, surprise, sadness, and disgust. Out of this, 4 emotions are the positive emotions, and 4 emotions will be considered as the negative emotions. So anger, anticipation, joy, trust will be considered as the positive emotions, and anticipation, surprise, joy, and trust. Whereas anger, fear, sadness, and disgust will be considered as the negative emotions. And we'll now to create the psycho-emotional mapper for our own work. So what we are doing, we are creating one stimulus pool. So to create the stimulus pools, we are creating some standard questionnaire, and that standard questionnaire dataset will be connected from OpenBCI and PhysioNet, and from that we are connecting the psychometric questionnaire surveys. What are the psychometric questionnaires, and based on this what should be the user's response, and that will also immediately collect, and the image database and certain video database also, and based on this we will put the survey, and a user will sit in front of the computers or the mobile and will try to give the answers of all the surveys, but that should be taken within the 35 seconds, because within the 35 seconds you can whatever response you will give, that should be your that should be your normal response, otherwise it may be the fabricated response. Now so for positive response, for positive emotions we have considered, for negative emotions we have considered, right? Now out of this we will find out that if the based on this, for positive emotions, which emotions is the driving emotions. That means if I give the marks out of 1 to 10, which emotion is getting the highest marks. So that will be considered as the driving emotions, and the rest of the emotions will be based on those driving emotions, how much marks it is getting. Suppose up to out of 1 to 10, Joy has for a particular questions, when he is responding, Joy has got the marks 7. That case, and the other is less than 7. That case, Joy will be the driving emotions, and based on Joy, what are the other emotions has already responded, that will be considered. So in this way we have taken only 20 sample stimulus for our initial survey. So in that case we have seen that out of this 20 sample, per sample we are generating the 800 emotional patterns, 800 responses for each survey we are generating. How 800 samples are being generated? So if I consider Joy has one driving emotions, in that case the others are the secondary emotions for that particular response, right? So for the Joy driving emotions we are getting 200 responses, and similarly in the next if I consider that the other response is suppose the trust. So if the trust becomes the driving emotion, that case the other emotions being the secondary emotions, how they are being responded. So in this way we are generating the 800 samples, and total numbers of samples being generated for the 30 sample size will be 2400. Now that is also for if we consider the only the 8 primary emotions. Now instead of the, if we try to consider the binary and the tertiary emotions, that case the number of sample size will be huge, and our structure or our pattern model will be more robust and significant. So it's a we have designed a prototype model for this one, so where only based on this 8 emotional patterns. So later on it can be considered the more than that. Now whatever results we got based on this 1 to 10, Joy, how much out of 1 to 10 scale, how much Joy has got, trust has got, anticipation has got, and submission has got. So based on this we have we will create the mean values of each of the participating emotions and be calculated, and from this mean we will calculate the standard deviation, and the standard deviations will be concluded that for a single user every variance models are generating good pattern, and the error correction level should be within 0.3 to 0.88, and from that we will generate the confidence Bell function. Bell function will give you the confidence level only. Now this is the work flow of our work. So we have considered only the taking the input from the keyboard keyboard and mouse. When you are logging in, you will be given some sets of questionnaires, survey questionnaires that is generated from OpenBCI and PhysioNet, and based on this questionnaire we will create one current sequence of buffer, and that buffer and for a particular users the previous storage emotional pattern is already generated, which is stored in this session sequence storage. Now this behavior, if it is seen that it is deviated from its normal session sequence storage storage behavior, that case we will try to analyze the pattern, and there will be two tuning factor is there, K1 and K2. So which will try to create one adaptive which will try to create one adaptive positional reorientation of this of this pattern, and we will try to check that whether if there is any abrupt response from your emotional sequence which is a little bit diverted from your normal sequences. So whether it is accidental case, or it is quite like this, that the same person is not giving the response. That means what I wanted to say, that suppose today yesterday you have given one responses, and for the last few days you have given one responses which are similar to each other, and based on this your psycho-emotional pattern has been generated. Now whatever responses today you are giving, your mood is not quite good today, so we are finding out there is a diversion from your normal emotional behavior. So that case what we can conclude, that the person is not same, or it may be that the same person is there, but today as his emotional behavior is exceptional, but person is same. So that can be derived by this adaptive positional reorientation, that will show you how it will be judged. So this is the algorithm, and the better if we if we explain this algorithm a little more. Suppose we are considering two tuning factor K1 and K2. Suppose right now we have considered t numbers of sequence for a particular user, and for this t numbers of sequence S1, S2 up to t minus 1, the number of generated pattern is P12 up to pt minus 1. Okay, now the pth pattern for the sth sequence, I find out there is some irregularity. So that case what I will do, that I will take the total length L, which is from 1 to t. So within this length L, the first value that is the K1, and the last value that is the K2, we will try to find out the subsequence of this pattern. So out of this subsequence, if this subsequence which is the most repetitive subsequence, whether it is matching with the new sequence or not. So if the most repetitive subsequence is matching with that particular sequence, that case we can say that okay, this behavior is little bit different, but the person is same. But if it is not matching, that case what I will do, that I will try to reorient the adaptive positional reorientation of this adaptiveness. What I will do, that the value of k will be increased by 1 and value of k2 will be decreased by 1, and I will actually squeezing the subsequence from length L to L minus 2, and within this subsequence whatever most repetitive matching subsequent is there, whether it is matching with that one or not. So in this way we will continue to decrease the subsequent value sequence value, and try to match with that new pattern, and if it is matching, okay, fine. After that, when K1 and K2 comes to the same place, that means there is no subsequence left, and still we cannot matches the entire pattern. That case I can say that the human behavior is something different, and the person is not same. And the total algorithm is shown over here, and in this case we have used the Darmstadt-Shepard rule combinations also, and this is the result. Actually this is a graph of the acquired behavioral pattern. So how each of the in the x-axis these are the different types of responses, and the y-axis the number of users, number of samples. So here the number of samples are 30, so this 30 numbers of samples, and based on the how they have responses. So we can say that the login, the series 1 in this case it is linear, the series 2 up to series 10, when it goes to the series 10, so it is little bit discrete in nature, and this is the emotional sequence plot. Now the main thing is that when we put it this total emotional mapping pattern, so the normal emotional mapping pattern A normal emotional mapping pattern is that the red mark one, and whatever the abrupt response sequence we got, that is shown through the white color and also through the yellow points also, and the yellow points is showing that there is a diversion from the normal sequence. But after the K1 and K2 reorientation, if it is coming nearer to red marks, that case I can say that the persons are same, but there is some emotional irregularities may be there. But if it is diverging, the white ones are diverging, that case I can say that these persons are not same. So this is the main continuity of this Bell function. Now the main thing is that where we can apply these things. So the first thing already we have discussed the business analytics and marketing. So if I can find out the human emotional behavioral pattern of all the users, that case we can judge that whether if I want to launch a particular product, so whether this product will mapping with this particular human behavioral response of that particular sets of users or not. So that case we have to take the results of we can take the values from the different cyber cafes from the different users also, and such kind of things are already being done through sentiment analysis also, but getting the user data is one challenge. And the customer relations also, so what type of customer should be sent, what type of messages, marketing product or promotional product. So that is also depends upon that the psycho-emotional cybercrime and security, that is not clinically experimentally proven, but this may be one scope. Prediction of election, which is already been done earlier through Facebook details, emotional robots, learning behavior of the students, HR management, psychological treatment. So well, thank you for your patient hearing, and thank you once again for giving me a chance to share one of my project areas. Apart from this, our students are working on several other IoT based projects also. As already I told, that is a new university, and running an university and a remote place like this is a big challenge, and we can say that we are successful in taking up this challenge also. And we want the more and more industry participation, so that our students can get more and more exposure. Thank you. If you have any questions, you can ask.